Here we have an exponential equation and we have to solve for x in this an exponential equation. Okay, let me write the given exponential equation as it is. That is 3 to the power of 2 positive x over 9 to the x power equals to 1 over 27. So here the base is 3 and here the base is 9, but 9 is a power of 3, that is it can be written as 3 square, and this 27 is also a power of 3 because it can be written as 3 cube. So I can convert each term with the base 3. Okay, let me do it. So we have 3 to the power of 2 positive x over this 9 can be written as 3 square whole to the power of x equals to 1 over this 27 can be written as 3 cube. Okay, now let's consider the power of a power rule in exponent. That is, let's consider the base a with the exponent m. Again, I consider an exponent n for the complete stuff e to the mth power. So whenever I have two exponents like this, what I can do is I can write the base over here and I can multiply the two exponents, that is m times n. This is a power of a power rule. So I'm going to use the power of a power rule over in this term. So because here we have base 3 and we have exponent 2, and for the complete stuff we have the exponent x. So what can we do with the two exponents? We can multiply them. Okay, let me do it in the next step. So 3 to the power of 2 positive x over 3 to the power of, when I multiply these two exponents, 2 and x, I'm getting 2x equals to, so here when I divide 1 by 3 to the third power, okay, if I move this 3 to the third power from denominator to numerator, so it will be multiplied by this 1 and this exponent will change its sign. Already the sign of this exponent is positive, so when I move this 1 to numerator, so the sign of the exponent will change, so it will be 3 to the power negative 3, and this 3 to the negative third power will be multiplied by the 1 which I already have in the numerator. Even when this 3 to the negative third power multiplied by 1, it will be the same. Okay, now here let's consider the stuff we have on the left side. So we divide two terms with the same base 3. So whenever I divide two terms with the same base, what I need to do is I have to write the base ones, and I have to subtract the exponents. That is, I have to use the coefficient rule of exponent. Let me write it over here. So here I divide two terms with the same base a. So here what I can do is, so I can write the base ones and I have to subtract the exponents, then I'm getting m negative n. So I'm just going to use the coefficient rule over here in the stuff on the left side. Okay, let me do it. So when I divide 3 to the power of 2 positive x and 3 to the power of 2x, I am getting 3 to the power of 2 positive x negative 2x. I just subtracted the exponents. Okay, now on the right side I can write the stuff as it is, that is 3 to the power of negative 3. Okay, now 3 to the power of 2 okay, now I have to combine the like terms over here, positive x and negative 2x. When I combine positive x and negative 2x, I am getting negative x equals to 3 to the power of negative 3. Okay, now two terms are equal with the same base. Whenever two terms are equal with the same base, what I can do is I can equate the exponents. So when I equate the exponents, what do I get? I'm getting 2 negative x equals to negative 3. Okay, now to solve for x, I subtract 2 from both sides. When I subtract 2 from both sides, this positive to negative will cancel out. I'm getting negative x equals to negative 5. Okay, here I need the value of x, but here I got the value of negative x. To get the negative sign over here, I multiply both sides by negative 1. Let me multiply both sides by negative 1. So negative times negative will become positive. 1 times x is just x on the left side. Negative times negative will become positive. 1 times 5 is 5. Now I got the value of x. The value of x in the given exponential equation is 5.